Okay, guys, so these aren't actually inequalities. I thought they were when I originally planned for this, so these are not inequalities, these are just equations. So what you need to be able to see here is this is a circle of radius 5. And it's being intersected by a line. So let me use to shape, and I'm just going to try to do my best to make a circle that goes through those points. So I go like this. Yeah, it should be radius 5. It's a little bit off, obviously, but who cares? We've got, this is x squared plus y squared equals 25. Obviously, if you did the conics, then you know that that is a circle of radius 5. Next, we have y is equal to negative 2x plus 10. Obviously, all I did was subtract 2x from both sides to obtain that. But I don't think that this is actually going to reach the other thing. So let's look at this algebraically. If we have y is equal to this, we can plug that in. We have x squared plus y squared, which is negative 2x plus 10 squared is equal to 25. I've just substituted this value into this equation for y. Okay, so now we have x squared is equal to x squared minus, actually no, x squared plus 4x squared. This times this, so I'm doing the distribution. 2x plus 10, 2x plus 10. So we get minus 20, so that's minus 40x plus 100 is equal to 25. Okay, so then this is 5x squared minus 40x plus 100 is equal to 25. Let's move the 25 over. We get 5x squared minus 40x plus 75 is equal to 0. I've subtracted 25. Okay, divide the 5 out. We have x squared minus 8x plus 5 goes into 75 13 times maybe. 75 divided by 5 is 15. Sorry, 15. Oh, so then this is x minus 5, x minus 3. I've done factoring. We have 15, positive 15, negative 8. We have negative 5 and negative 3. So then x equals 5 and 3. Okay, so we got two solutions. Now, how do we figure out where those solutions belong? Well, if we plug 5 into this y equals negative 2 x plus 10, we get y equals negative 10 plus 10, or y equals 0. So that means 5, 0 is a point on the graph, so it must intersect here. If that was at 5, but it looks like it's off. And then if we do 3, y equals negative 2 times 3 plus 10, which is negative 6 plus 10, which is 4. Then 4, 3 is a point, so 4, 3 would be somewhere like right here. So this line goes like that, and you can see those are the points of intersection, and therefore the solutions to these systems. Okay, let's do another one. Let's do example 3, and then we'll do 4, and then we'll be done. So we got 4x squared plus 9y squared equals 5, but they say y equals x squared. Okay, so let's plug that in. We have 4x squared plus 9 times x squared is equal to 5. So I plugged this into y squared, which is 4x squared plus 9x to the 4th is equal to 5. So this is, let's see, 9x to the 4th plus 4x squared minus 5 is equal to 0. Let's see if this factors. Who knows? Maybe it does. It's not perfect square trinomial, but we've got 9x. We'll say this is 9x squared and 9x squared. I'm using x squared, obviously, because this is x to the fourth. This is negative 45, and we want it to add up to 4. 15 times 3 doesn't give you 4. 9 times 5 does. Okay, so 9 and 5 works, so that's going to be a positive 9, a negative 5. Let's cancel. This cancels. This is 1 and 1, so this is x squared plus 1. And this is 9x squared, 9x squared minus 5. Okay. So, what does that tell us? Let's see. Just making sure I've not missed anything. This never equals 0. Remember, that is an imaginary number if you set that equal to 0. That's x equals I and negative I. This, however, does. So 9x squared minus 5 is equal to 0. So then if we solve this, 9x squared is equal to 5. We divide by 9. X squared is equal to 5/9. So square root x is equal to plus or minus square root of 5 over 3. Okay. So that's that. And then we plug that into one of the equations. Let's do y equals x squared. So if we plug that in, we have y is equal to, we use the positive version. Oh, I guess they both give the same answer, right? 5 over 3 squared, which is y equals 5 over 9. And for the other one, if we do the negative 5 over 3 squared, we get the same thing, 5 and 9. Okay, so we don't need that comma there. So we've got the same answer. So our solutions are square root of 5 over 3 and 5/9, and square root of 5, negative square root of 5 over 3 and 5/9. Okay, so that will be our solution for this one. And then finally, we will do the last one. I'm going to do this one using elimination this time. We have 3x squared plus 2y squared is equal to 36. And 4x squared minus y squared is equal to 4. I want to eliminate y because this is negative, so I can multiply this one all by 2 to get negative 2x or 2y squared. So I've got 3x squared plus 2y squared equals 36. If I multiply the bottom by 2, I have 8x squared minus 2y squared is equal to 8. Then, oops, didn't mean to do that. What did I do? There it goes. Okay, we're almost back. All right. Then we add these together. This is 11x squared. Gone is equal to 844. We divide by 11. X squared is equal to 4. Square root, x is equal to plus or minus 2. We will plug that into one of the equations and we will solve. So we have 4x squared minus y squared is equal to 4. So let's plug 2 in for x first. So we have 4 times 2 squared minus y squared is equal to 4, which is 4 times 4. So 4 times 4 minus y squared is equal to 4. 16 minus y squared is equal to 4. And therefore, negative y squared is equal to negative 12. Divided by negative 1. Y squared is equal to 12. Y is equal to plus or minus, square root of 12 is 4 times 3, so this is 2 square root 3. So one of our solutions, or two of our solutions are 2 and 2 square root 3, and 2 and negative 2 square root 3. So notice that I got 2 answers for that one. Now we do the negative. If we do the negative, it's going to be the same result, guys. So we have 4 times negative 2 squared minus y squared equals 4. This is going to be 4 times 4. This is still 16 minus y squared equals 4, which you can see right here is the same thing. And so we get negative 2 2 square root 3 and negative 2 square root 3. This time we had 4 solutions. The reason is because if you look at these, I believe this one is a hyperbola and this one is an ellipse. And so you have something that might look something like this. And so you'll have 1, 2, 3, 4 points that meet. And so you can see 4 solutions with these.